This is statics. With statics, there's something called the equilibrium condition, where we sum all the forces, and when all the forces are summed, it must equal zero. So that being said, if we're summing over I of our forces for I equals 1 to n and the n forces, then there must exist a negative component of these forces, which is what this means. So if an object is modelled by a particle and is acted upon by n forces, F1, F2, F dot 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 Fn and so on, then the equilibrium condition is here. Now here's an example. A particle which remains at rest is acted upon by three forces, F, G and H, where F equals 7I plus 2J, G equals minus 9I plus 3J. We find the force H in component form. So using this, as we've just said, the equilibrium condition here, so we already know G and F, so we're just H equals minus F minus G here, and then multiplying out collecting terms and so on. This is the final answer for H. Now here's another example. A force is acting as a magnitude of 3 newtons. It's acting in the direction given here pictorially. Now it's 60 degrees from the vertical, and here is our axis, I and J. So from this diagram we can see that F equals minus 3 sine 60 I plus 3 cosine 60 J. Now we're putting this back, plugging in the values for these because they are regular angles, sine 60, cosine 60, and they do have exact values. We get this in component form, and that's in fact, another note, when dealing with statics, well in general I would say, if we're dealing with these kind of things like forces, where we are dealing with something that's either like a tensile force that's trying to pull things apart, or a compressive force that's trying to push it together. Now an example of this is concrete. Concrete has very weak tensile force. So let's say if you have a long concrete beam here, and it's placed here and here on top of two walls. Now this has a very weak tensile strength, which is acting here and here. So we would get a crack and then the thing will fall down here. So it has very weak tensile strength, but on the other hand it's used in foundations and things like that for buildings, and it has been for thousands of years I believe, because it has high compressive strength. So so if we're to use concrete for things like this, like which we actually see, and the reason why we do see these on bridges and it doesn't collapse is because it's reinforced with steel inside it, which the steel itself is winded, so it has these kind of ridges which helps lock it with the concrete, the steel, because steel has very high tensile strength but doesn't have as strong compressive strength. But when we put the steel rods within the concrete, that actually gives the concrete high tensile strength, so we can then use concrete for other things, because like bridges, because concrete's a very cheap solution to build large infrastructure projects and whatnot. But that's just an extra added note. Please do like and subscribe. I've got plenty more videos to come.